Okay, so locker number 90 was the answer.
That's right.
And so your factors were 1 and 90. Actually,
Jeff was, but I had to write it down. He figured it out.
I'll tell you what, guys, as part of your notes, because we're going to use this in the next example, what I want you to do, I'll pause this here in a minute. I want everybody, because we're going to start taking notes, everybody write down the 12 factors of 90. Okay? You can use your multiples sheet or your calculator. Okay?
Oh, I got 12. No.
Now,
You're supposed to have 14 and a half.
Oh, I got 12.
let's list these off. Emily, can you give me the next pair? We had 1 and 90. Say it again. Even before that.
1 and 90.
2 and good. 2 and 45. Hold on. Don't give it yet. 2 and 45. Nathaniel, what's the next one? Ben?
What?
What's the next pair?
3 and 30.
Okay. Gabe, the next pair?
5 and 18.
Yeah.
Okay. Next pair. Brittany, do you have another pair? Good. And the last pair, Joshua? Okay. So there are 12 factors of 90. Okay.
How's that 12?
That's 12.
Count the 1, 2,
1,
3,
2.
4,
12 total.
1, 2, 3, 4.
1, 2, 3, 5. What your mathematics is.
Okay. Now, here's our first example. If we wanted to find the GCF, which is the abbreviation for the greatest common factor, okay, of 36 and 90. Now, Brian, you think it's 9?
I do.
Halfway in between.
Let's write them down again. I'm going to write down.
What if I could do this in my head?
I'm gonna have to say 45.
Here's what you do.
I don't even know if
36.
it's common.
Oh, 36 and 9, never mind.
It's 10.
No, it's
It's 9. It's 9, guys.
Oh, yeah.
I figured it out. It's 9. I figured it out. Not the greatest compact.
Okay. Now, guys,
9.5.
hey, just listen. Just listen. 36, we have 1 and 36. This is what I'm going to have you do on your homework. When it asks you for a GCF, you're going to list the factors of both. I know some of them you can do in your head, but to get good practice with factors, we're going to write them down. So we'll do that first. 1 and 36, 2 and 18, 3 and 12, 4 and 9. Now we're looking for what?
Greatest.
The biggest one in common. The biggest one in common.
18.
Hey, I was only 9 away.
That's the biggest one in common. So we would say the GCF for 36 and 90 is 18.
I was wrong.
So you list both sets, list the factors of both numbers. Okay? The purpose of greatest common factor, does anybody know how you can use that with fractions?
Nope.
Find like the denominator and stuff.
like if you have two different fractions.
You're close, Gabe. That's going to be with LCM coming up. We're going to use that the least common multiple, or like when we're going to least common denominator. We're going to get that in a little bit. What would you use greatest common factor for? Why would you want to know the greatest common factor for two numbers? If I gave you a fraction 36/90ths, what would be the fastest way to reduce that fraction to put it in lowest terms? So you would,
Maybe if you're like buying something. Like, figure out how many times it goes into an 81, you can spend like you're spending like $90, then like.
say if an item was $3 or something.
Yeah.
Right. What I was going to show you, how would you use 18 to put that fraction in lowest terms? Yes. We divide them both each by 18. You would get 2 and it's 5 times 18? So 2/5.
Oh, yeah.
In other words, you could break it down other ways, but dividing by 18 will be the quickest, because 18 is the biggest number that divides into both 36 and 90. Okay, let's take a look at some other examples. These are a little smaller. So what I want you to do, I'll give you a little bit of time. I want everybody to do this. Write out, I want to see your work. So write out the factors of 9, and write out the factors of 12. And then write out the factors of 18, the factors of 24. I'll tell you what, we'll skip this bottom example. We'll just do those two. Just do those two examples.
It's when they all had skateboards and they dropped around.
Yeah, that's what I said.
Okay, guys, let me have you back here. So, we listed the factors of 9. Guys, factors of 9, factors of 12. The biggest one in common between the two lists is 3. We got list factors of 18, factors of 24. The biggest one in common between the two lists is 6.
How come they want to
Okay.
stay in a row?
Nice job. That's okay. Now, let's take a look at this problem. It's a little different. The county fair, every 12th person through the gate gets a free ticket. Every 30th person gets a free T-shirt.
A free T-shirt and a free ticket?
You get both.
Anybody? Yes. Anybody know who the first person, where would you want to step in line to get both of them? Who's going to be the first person to get both?
The 30th.
What's that?
30th, 60th?
No, every 12th gets a free ticket.
36.
No, because you got to be at least the 12th person in line to get a free ticket.
Right?
No,
T-
60th. 60th.
60th would get it.
Who said it way before?
Wait, whoa,
Okay.
I thought that
No.
the 30th person gets a T-shirt and a ticket.
Every 12th person shaves it, do 5 seconds, 2 cents.
So why don't you just be the 30th person and just make everything easy?
6 times 10 is 6.
Now, hold
My God, can't process this.
on. Now, you guys, this is taking too long. Just listen. Okay. Now, for this one, we're not doing factors. We're going to do multiples, right? Because, like, the 12th person gets a free pass. The 24th person gets a free pass. The 36th person gets a free pass, right? So we want to write down, instead of factors, now we're going to do multiples. So we're on multiples of 12. So 12 24, 36, 48, 60, 72, 84, and it keeps on going. How long is the list of multiples going to be?
Forever and ever.
It's infinite, doesn't end. So that's a big difference between factors and multiples. Factors is a finite list. You might have 12 factors or 9 factors or 2 factors, whatever. Multiples keep going. There's no end to the list. Okay? Now if we do the multiples of 30,
30, 60, 90, 120.
so 30, or you could think, if you want to think of it also, like 30 times 1 is 30, 30 times 2 is 60,
3 is
30
90.
times 3 is 90.
4 is 120. 1/5, 30.
180.
So these are the, guys, if you have a huge line, these are the places that are going to get free t-shirts. So if you notice, like you guys said, the 60th person in the line, that's the first match. And now we're looking for, instead of finding the biggest one in common, we wanted to find the least one in common. So we call it the LCM, the least common multiple. So that's the least.
Wasn't the 120th too?
Yes, you're right. The 120th. But we wanted the least one, the smallest one. Okay, but you're right. You'll end up going, you'll just keep adding on 60. So the 120th, the 180th, okay? That's the LCM. So let's just take a look at, just for the sake of time, let's just do this first example. What would it be for, let's list our multiples of 6.
60.
So we got 6, 12,
24, 30, 36, 22.
okay, multiples of 10, 10, 20, 30, there we go. And when you do your homework, you guys, you can just go until you see the match and then you can stop. So here's our match. That's our least common multiple. No. You got to write them down. Okay. Now, Gabe had mentioned before, the least common multiple is, say I'm adding 2 fractions. Say I want to add up 5/6 and 9/10. Okay. The smallest multiple that 6 and 10 have in common is 30. That's the smallest number that I can get 6 and 10. I can multiply them by something to get their denominators in common. So in other words, I would multiply this by 5, then it would be 25/30ths. And I would multiply this by,
I said 3 earlier.
so then I could add them up because the
Why'd you
denominator,
do 3?
because I wanted to get 30. 30 was my common denominator, or my least common multiple. So we would have, you're right, 52/30ths. Okay? Because you need a common denominator to add them up. So that's the reason for learning least common multiple. Now, before I come to our practice here, I also need to show you prime factorization.
Never heard of it.
Give me, so I'm going to give you, we'll do a couple examples here. For our first example, I'll do 100, okay? First off, what's a prime number?
1 in itself.
Can only be divided by 1 in itself. So in other words, yes. If we list 1 is prime, what's the next one? 2, 3, 5's prime.
7. No.
7's only divisible by 1 in itself. Let's see. Yeah, 8 isn't, 9 isn't, 10 isn't, 11. You're correct.
13.
Good job. Very good. 18 isn't.
23. 23.
21.
21 can be divided by 7.
Right.
That's 3.
What about 19?
No.
Nine. 19 is prime.
23.
22. Or no.
24, no. 25, no. 26, no. 27, no. 28, no.
27. Yeah.
29. Okay, we can keep going. I just wanted to give you the first couple there. Okay, 2 and 13. If it's, you can't have an even number as prime. The only even number that's prime is 2, right? Because otherwise, any other bigger even number is going to be divisible by.
Yeah, but 2 can be divided by 1.
Right, can only have a factor as 1 in itself. Yeah. Now, to do prime factorization, here's how you do it. If you've probably done it before with the little factor tree, we won't worry about 1 because that just starts out to be just 1 times 100. That doesn't really break the tree down. We still have 100 there, like what we started with. So what you just do, skip 1, go up the list then, go to 2. You just work your way up the list to build your tree. So you would go 2 and 50, you're right. Then you start breaking down 50. Yeah, you skip the 1. So you start with 2, so you get 2 and 25. 25, go up the list. We can't do 2, we can't do 3, so we go to 5. 2 is a prime number, so you don't have to break down that it's a prime number. So, what do I get for my answer for my prime factorization?
2 to the second power times 5 to the third.
Yes, very good, you guys.
What?
Are you minus that?
In other words, what we did, you guys,
Are you minus that?
we've broken 100 into multiplying just prime numbers because 2 is prime and 5 is prime. Okay, let me give you another example. Let's do something like, let's say, what would be another good example? Let's do
90.
72. 72, okay?
1.
So we've got, again, for your factor tree, just work your way up the list. So we'll start with 2.
36.
2 and 36. Then we'll break down 36.
36, 3 and 12. 4.
Well, remember, you always want to start with the smallest prime that you can.
2 and 18.
2 and 18.
2 and 18. So
2 to the 4.
just follow down the left edge of your tree. So 2 to the 4, 2 to the third, and 3 to the second, right?
3 to the 4. How do you get second?
There's 2 3s.
3.
That's 3.
Okay?
Are you doing homework on this?
Yes. What you're gonna do,
Can we like have the movie playing and if you want?
and actually,
Again.
let's see, I'll just give you time to work, so let me just pause this.